an integer and the y-axis. Okay, so for number 1, what is the y-intercept? Well, I'm going to have to find the slope in order to extend the line. That's what I meant. Yeah, what is the pattern here? Up 2 over 1. So I'm going to go up 2 over 1. Up 2 over 1. So if this were a line instead of a ray, the y-intercept would be 5. So now I'm going to challenge you to write the equation of this line. So that's not written up here. I want an equation of the line. Y equals mx plus b. Eva.
Y equals 2x plus
5. Okay.
Is that right?
Everybody agree? Torian, you're in agreement? 2x plus 5? All right. So now I want to challenge you to write an equation of the ray. No, how would we show mathematically that this is a ray, that this actually doesn't go here? How do we show? So this is the line. The ray is y equals 2x plus 5. It would be a negative slope. You got it, Paige? So you got it. All right, so for the equation for the ray, it's the same thing. It's the line. Does anybody have a question how I got the blue equation before I start talking about the ray? Okay, we just paired the slope with the y-intercept. So the ray has an if statement connected with it. I think you got it. Just that. I think I'm good. I think this is it. Because it goes on forever this way. You only show restrictions with the domain. And the range will just come out that way. So how do I say that this is an array? I use an if statement. So y equals 2x plus 5 only if and when x is less than negative 2. So right here where x is negative 1, this line does not exist. And where x is 5, this line doesn't exist beyond x equals negative 2. So this line only works if the x value going into it is less than or equal to negative 2. That's what makes it an array instead of a line. So we show this endpoint with this if statement regarding the domain. Okay? Let's do number 2 then. So I'm going to ask you to do this for number 2 as well. Oh, we can't because it's not an integer. Let's take a look. This one, I wanted you to see they don't always go through a perfect spot. So let's find the slope. Who found the slope for number 2? Somebody else, okay?
Up 1 over 4.
Up 1 and then left.
Oh, wait, hold up, 3.
3. Okay, since it's left 3, I'm going to show that as a negative, right? Yeah. Yeah, if I said that out loud, I would have said down 1, right 3, because I always say right. We talked about that before. Gabby, you're totally fine. Go up, and that's positive 1. If you go left, you're going in the negative direction. Show that as a negative 3. So the slope is negative 1/3. So when I go up 1 and over 3, 1, 2, 3, this is my next point. I extend my line. That's not how you extend it. Up 1, 1, 2, 3. That is right on the axis there. One, 1, 2, 3. Up 1, 1, 2, 3. It would go right here to -1. Are you with me, Autumn? Why not? Oh, because it's the x-intercept. Thank you. All right. So here's our y-intercept. Our y-intercept is between 0 and -1. Okay, and sometimes you have to describe it like that. It's not always on an integer. So I'm just going to pick a value so that you guys can make an equation. I'm going to say that it's approximately -0.2. I could probably calculate it, but let's just go with that for now. Number 2, let's write an equation for y equals mx plus b using our intercept at -0.2. Yeah, the restriction. Desiree, what's the slope? Down 1/3. Down 1/3. Where does the slope go in this equation? M. What's the b in this equation? Do you know what b stands for? The y-intercept. The y-intercept. Yeah, let's just put that in there. There's your equation. That's all I'm asking you to do. Plug in slope and y-intercept. So now, so if it was a full line, if the arrow continued left forever, this would be the equation, but it's not a full line, it's a ray. So it doesn't go on forever. So I'm going to say the equation for the ray is -1/3 x minus 0.2, but I'm going to assign an if statement regarding x. If x is what? So does the green go through x is 1? It doesn't. It doesn't go through x0. It doesn't go to any of these negatives. So x, when you focus your attention just on the x-axis, not on the y-axis, ignore up and down, and just look left and right. What value does x begin on? Right here, 1, 2. X is 2 where this starts. X begins 2. Well, our x is going down or our x is going up this way. X's are getting bigger going to the right. So this is x has to be greater than 2. This is a stipulation that makes this a ray. It's a full line, but x has to be greater than 2. That's the answer. Why did I use a greater than sign and here I used an equal to? Because of the open circle. If it's an open circle, my if statement isn't equal to. If it's a closed dot, my if statement is equal to. Yeah, it was just identifying the y-intercept. It's the same direction for both of them. All right, so I'm gonna pause. I'm gonna walk around and see who did their homework. If you read the book, you saw that. Wait a minute, this looks like something I've never seen before. Your notes yesterday from the book. Did you understand what you wrote?
No.
So maybe read this and think about it. Not just write it, right? Think about it. You don't even have to write it. I want you to understand it. A piecewise function is a function made up of 2 or more expressions. So it's going to be like a ray and another ray. And they call it all a part of the same function. So they're breaking down a line. And instead of it being one continuous line, it's called discontinuous. They pause in the middle and they make it a different line altogether. And it's just a function broken into pieces. Several pieces on one graph. So you use the description of the x value to determine which piece is which. So the if statement in the piecewise function that tells you how x is restricted is how you figure out what you're looking at. You really have to focus your attention on the x-axis. So we're going to create graphs looking at these piecewise functions. You graph the entire line, so you need pencil. We're going to graph an entire line, and then we're going to erase the part of the line that shouldn't be there. So we erase according to the domain restriction. So if I had to graph the rate in Bellwork, I would do the whole line, and then I would look, oh, x can only be less than -2. I would erase everything above it. That's how we're going to graph, with erasing. That's not what your book told you. Your book didn't say, well, draw the whole line and then erase. That's a great way to do it. They just, boom, appeared a graph for you to look at. It's really pretty difficult without graph paper. So if you still haven't acquired any graph paper, I'll bring it.
No, it isn't. Okay, so does it sound like realistic if I slow this down that my dog is throwing up and take it to the vet? With the whole thing, kind of the volleyball, with the volleyball, to the whole 2 o'clock.
No. She's gonna tell you that in the morning.
Yeah, I didn't get home till 2 o'clock in the morning last night.
She's gonna say that stuff.
Because my mom went up to get home. Because she went to go watch the football game.
She's just gonna. Alright, we're gonna grab this guy. Here I come.
Wait, I wasn't done.
Yeah, this is legit. Everyone has to write this down. I can throw that up if you were still writing that. I apologize. This is a must do. We're definitely gonna create this graph. Yeah, my first thing I was gonna tell you to do is just to write this equation with y. That's step 1. I'm gonna write it. I'm gonna write it right now. Step 1. You know what I mean? Step 1. Write with y. You know what I mean, Jackson? You know what I mean or no? So that could be helpful. And if that's something that you know and do naturally anyway, then you're not going to do step 1. You do it naturally anyway. So I'm going to write, instead of f of x, the way it's presented, I'm going to write y equals x plus 2. That's my first one. My other equation is y equals x. So this is 2 equations representing in one function. So you can look at the 2 parts as their own independent lines when you graph them. So step 2, graph them both. So we're going to graph line 1. Then erase according to the restriction. So we graph and erase line 1 before we hit line 2. So how do we graph y equals x plus 2? Choose the y-intercept. What's the slope? Yeah, m is an invisible 1. 2 is the y-intercept. You're going to begin here. We're going to begin at 0, comma 2. The y-intercept, and then go up 1, over 1, up 1, over 1, graph your line. Go ahead and do that. Go ahead and graph that linear equation. Really stepping out here, not on graph paper. So I'm beginning at 2. Here's my dot. Now going up 1, over 1, up 1, over 1. Some of y'all are going to get lucky because you don't extend lines anyway. I hope you have your eraser ready. Required erasing. So positive slope starting at 2. Okay, so now we're going to consider this restriction. It says if x is less than 0. So that means we're going to have to erase any x greater than 0. Oh, I'm sorry. I said that backwards out loud. This if x, oh yeah, I wrote it out loud. Greater than 0. Yep, we're good. So if x has to be less than 0, well, that means here where x is 1, this doesn't exist. And where x is 2, this doesn't exist. X is 3, this does. None of this stuff exists if x has to be less than 0. So just get your pencil and erase everything over this side where x is more than 0. Additionally, it says that x is less than 0. It says x does not equal 0. So I'm also going to make sure I do an open circle. When you're done, go ahead and try to do the second piece of the function. Do it on the same graph. So right here in the same coordinate plane, we'll do the second piece of the function. So our second equation is just y equals x. This stumps so many people because there's no numbers. Gabby? Yeah, there's like an invisible 0 here. So we'll begin at 0. Begin at 0, 0. It is parallel. Nice one. Move up 1 over 1. Same slope. You erased the wrong side, I think. Oh, no. Because so these are still functions, so the vertical line test still applies. So you shouldn't like have any overlapping lines. So okay, I'm gonna start at 0 and go up 1 over 1. So yeah, it should look parallel. Since you're on graph paper and your lines are really straight and beautiful. So I graphed it. Now I'm going to erase according to the restrictions. So this is if and only if x is greater than or equal to 0. So we have to erase anything less than 0. X has to be more than 0. So I shouldn't be on the left half of the graph this time. This is the negative side. So these are like breaking the restriction rule. So here I go erasing. Fill in my dot. And there's my graph. So it's a piecewise function because it's broken into pieces. And so here, this is a hole, but it's filled in down here. So for this function, x can be 0. When x is 0, y is 0. When x is -1, y is +1. That's for another day. Okay. Any questions? Yeah.
In the notes, it said identifying the domain and range. I know there's the x and y value, but how would you do it for a piecewise function?
Let's do that. As long as the lines are going left and right forever, and it's filled in the middle, this domain and range is all real numbers. But it depends. Every piecewise function could have a different domain and range, so you can't just memorize that fact. But this one goes left forever. It comes in here. It's filled in, and in one of the 2 places or 3 places, the dot has to be closed for it to be all real numbers. And then it goes on forever. So the domain and range for this one is all real numbers. But each one's going to have kind of a unique look. Okay, let's try to fit one more in. This one's more complicated. It's 3. This one has 3 pieces. It's an infinite plane. Look at this restriction. X is in between -1 and 5. That's how it breaks down the middle. Cool, right? That will drive me. This is SAT right here. You're supposed to be learning and growing. It's not supposed to be like stagnant. Learning and growing. We don't want to stay stagnant. I just want to remind you what y equals -2 looks like. It's a 0 slope line, horizontal, at -2. So this reads, y is only -2 when x is less than -4. So less than -4. So I'm going to find the x-axis where x is -4. I'll do an open circle, and then I start my erasing. And there it is. There's my first piece. The more you do this, the more you understand how to separate x and y in your mind. To see just the x values and not the y values. Yeah, this is it. This is all we have to do and we're done. You can do it. You want me to wait? Maybe I'm freaking you out. Let me just wait. Yes. Yeah, were you not here when I passed them out? Okay. Can you come in after school or no? Not really?
I don't know because I have a twin brother, so I don't know who's gonna want to come here.
I mean, like ever.
Oh yeah.
We just tell him to come in. He can come in here too. He'll wait. You gotta negotiate. Okay. You're supposed to stay in your seats till the bell rings.